So to calculate this pressure across the depth, we draw a hypothetical cylindrical area. So we have drawn this cylinder which is just inside this surface. So there is this point B here and there is this point C I have taken here. They are just outside the cylinder. So due to the pressure at point B, the force onto the cylinder will be applied perpendicularly downward. And due to the pressure at point C, the force will be applied perpendicularly to the surface in upward direction. And again, as you see, with respect to the observer, everything is in equilibrium. So since everything is in equilibrium, the net force acting onto this hypothetical cylinder has to be 0. So let's make the FBD for this. FBD for this cylinder. So the force from up is coming down, that is FB. The force from down is going up, that is FC, and there is this weight of this hypothetical cylinder. There is mass, there is a liquid mass inside this hypothetical cylinder. So that will be equal to the volume of that. Volume will be A into H multiplied with density of the fluid. Let's say that density is rho, as we already defined, multiplied with G, because this system is placed in uniform gravity. Any other force, there is no other force acting there. And acceleration again is 0. So net force has to be balanced. So if I balance the net force, this Fc will be equals to Fb plus A rho G H. So we want the relationship in terms of pressure, not in terms of forces. So let's convert this Fc and Fb in terms of force. So as we already know, this force upon cross-section area is the pressure. So if we are taking force at point C, we need to calculate, or we need to take the pressure at point C. So Fc will become pressure at point C multiplied with the cross-section area of that cylinder. And that will be equals to pressure at point B multiplied with the cross-section area plus A rho GH. Or it will be equals to PC is equals to PB plus rho GH. So this is the relationship, and as you already know, this PB is nothing but PA, which is the atmospheric pressure. So this relationship we can write as PC is P0 plus rho GH. So if there is a fluid which is placed in a uniform gravity and which is at equilibrium, in that case, corresponding to the depth of that fluid, we can make the relationship of the pressure. So pressure at the depth will be equals to P0 pressure at the surface plus rho GH, where rho is the density of the fluid. It has to be uniform again. G is again gravitational field. Again, it is a constant, and H is the depth. When we measure the depth has to be perpendicular to the surface. So this relationship, with the help of this relationship, we can measure the pressure at different points within the fluid, if the condition will follow.